Okay, ready? Sure. Okay, so welcome to the 10th Never Ending Conference. Thank you all for coming. This one's very special because it kicks off the Global Game Jam. So this is something that you can put on your resume in the future, that you kicked off the Global Game Jam in 2013. So I do want to give you one announcement. Unfortunately, Freya had an accident on the ice. She will not be able to present today. So there will only be one downstairs at the P005 after this one's over. So it's about 20 minutes talking, 10 minutes questions, give or take a little bit. But do try to be a little bit on time so that we can start each one on time. And enjoy.
Quickly come in because we're about to start. The laptop on?
Hey. Would you like the lights off?
No. Well, for the video, and after that, I guess we'll keep it on, otherwise the camera can.
I think we're set. We're good.
Right, thanks. All right, so welcome to my presentation for my graduation project. My name is Erwin Heijns, and I'm going to be presenting about my procedural definite map generator project. Before we start off with the explanations and such, I'll first show you a short demo reel that will give you an idea of what the project is about. So first I would like to explain what my project is about, or rather, how it works. Firstly, this is a procedural level design tool. So this isn't a completely automated tool. It's actually a tool that the designer can use to rapidly prototype levels. He can use it to quickly test his ideas out. If he has one, he can quickly create a level, let the tool generate all the geometry for him. And secondly, you can also use it to discover interesting outcomes. So one idea, for example, is to use the sliders to quickly go through the possibilities for each step in the process, and then pick the ones you like, so you can quickly turn out to a workable level. Next to this, you could also integrate this into a game, so players could create their own levels. This way you can ship more levels with your game. Basically, players would create them themselves, and they could share them online. You could download them and play them example, Little Big Planet has a similar system. So I started by analyzing unrolled tournament tree deathmatch levels. I did this by analyzing the levels themselves, figuring out where pickups were, how they were created in terms of rooms, corridors, etc. And I also did playtests in which I captured heat maps. These heat maps captured data like where did players die, most often how did they walk throughout the level, what pickups did they pick up. And eventually I chose for the Axon style deathmatch levels from an unrolled tournament tree. These levels have a couple of interesting characteristics, mainly they're grid-based, they're industrial, they're indoors, and they're multi-leveled. The reason I chose grid-based is because this was a prototype. I wasn't actually sure how I was going to do it, so I chose for grid because it's easier to construct something on just the 4 axes rather than to deal with 360 degrees. It's the same reason why I chose for industrial environments because they're more blocky, whereas otherwise it could have been organic, which would have been harder to do. However, I did figure out some ways of doing it organically afterwards. It's just not in this system. Next to this, I also picked indoor levels because in terms of procedural level generation, several levels have already been generated, several systems I mean have already been created that produce, for example, height map terrain. Just Cause 2, for example, had a system such as that. It created a massive open terrain, but the only thing it really has to deal with is slopes that the player cannot traverse. So indoor environments are much more complex. You have to think of, for example, multi-level environments. Can the player get stuck in a room he can't get out of because the doors are too high? Or how do you make this fun? So that's why I chose for a user-mediated system, where a designer controls the system. It also it allows for a designer to rapidly construct the level, and it also retains a high level of control, whereas a completely automated system might not actually do this. It's harder to do that. So that's why the system has 3 levels of control. We start off with the semi-automatic generation. This means that the system suggests outcomes and presents a base. In the yellow field here, you can see a couple of parameters. There's some seeds in there, so you can change the random outcome. There's limitations to the random generation, and there's basic values such as corridor width and corridor height for the general level. Then we have the user overrides. So think of this. You have 5 corridors that you've just generated by using the random seed. You like 4 of them, but you don't like 1. So what you can do is, instead of reshuffling the entire thing by just changing the random seed, you can go into the 1 corridor you don't like, reference its number, select the right tab, and then change the parameters for that corridor. You can change where the corridor connects to and how it runs, for example. If you don't like that, you can also draw them yourselves. You can use a simple line drawing tool to simply place points where the corridor should go, and it will create a corridor for you. And this also works, for example, for rooms, objects, catwalks, etc. So next up, I would like to explain how the workflow of my generator. So we start off by creating the landmark areas of your level. These are the large rooms in your level that the player tends to remember. Also, they have more height levels than your general rooms or your corridors, of course. And after we have these rooms, we can define their boundaries. So the outer boundaries around them, how far can the corridors extend from them, and for example, the rooms and such, can they go over these areas, can they go below, or did you just go around the landmark areas? Once we have these rooms, we want to add doors. So generally you want to have more than 2 doors, because if you just have 2 doors, it's just a glorified corridor. That doesn't really create much rhythm and gameplay. So we add 3, 4, or 5 doors, depending on the size of the room. Then we connect corridors to the doors. This can be done automatically. As I said, you can just switch through the seeds and it will generate connections between them, or you can draw them yourselves. And with these, wherever they cross one another, wherever the corridors cross, it automatically creates a small room. So you have a bit more room to play when you come to a crossing. Also, you can add additional spaces. So you can, for example, cut a hole in the room to create a death pit, or add additional spacing in a long corridor where you can have a bit more space to do something, like place a pickup there. Once we have all the geometry assets like that, we can combine them. These are basically all voxel volumes. They're combined into one large voxel volume. This is then converted to a geometry object. It also identifies different areas, applies textures to them for the floors, the walls, and the ceilings, as well as the different areas. So you can see the large landmark areas are blue, the smaller rooms are yellow, and then you have the green corridors. Once we have this, there's still one problem though. Some of the rooms, especially the landmark rooms, have different height levels. And you cannot always traverse them from a bottom level to a higher level. So instead of going around, we want to add things like catwalks, ramps, and bridges. This can be done in the same way as corridors are placed. You just draw a line and places it. You can also make the system do it by itself. Once we have all the traversable geometry, we want to add some more diversity. We want to add some cover objects. We want to add some pillars, for example. We can place columns or pillars, and we can also place the fences on the ledges. This can be done manually, and you can also do it randomly if you want. The system can then distribute it on its own. As I said, you can do it manually, so you can simply, for example here, you can paint the railings on the ledge, and that just works really simply. You just paint a color, if you paint it black, it removes it. Next up, once we have all the geometry, we want to create a grid. So we do this by placing points along the floors, and then connecting them. And where there's geometry in between, it doesn't make a connection. So it basically creates different types of connections here. You can see the red ones, those are ground connections. There's the ramps, those are teal. We have the purple ones, those are really long jumps that you can only do with jump boots or rocket launchers. A bit more on that later. But first, we have the pickup distribution. The pickup distribution deals with 6 archetypes of pickups that you can find in the UDK. So there's weapons, there's the special type of pickup, then there's power-ups, armor, health, and ammunition. Pickups are basically placed in that order, and they also are defined based on their individual placement rules. So within each archetype, there can be a set of different pickups that have their own placement rules. So the pickup distribution is done automatically basically, and you can suggest your own pickup loadouts. You can press just a button, and it will give you a pickup loadout that fits to that level size, and it takes into account the types of pickups that you've already defined. Also, each pickup, as I said, has its own placement rules. Once we have all this, last step is to just decorate the level. The system automatically takes a large mesh and it cuts it up into segments, and then it takes tile sets and it assigns those to those segments. So you basically get this. And you can replace those segments if you want. You can, for example, change this to a temple theme or maybe some kind of castle. So that's all rather easy. You just have to model a new set. Once we have all this, we can just export it and then import it into UDK. Besides setting up the UDK level itself, you just have to import it. It can be done in less than a minute, and we're ready to playtest. Alright, so lastly, I want to discuss some of the things that I've created in my generator and how they work. I would like to discuss some of the key components, such as the grid, the corridor matrix calculation, AI path grid construction, and pickup placement. To start off with the grid. The grid is a key component of the system. As I said, I chose for a grid because the prototype would be easier, but I've used it throughout the entire project. So, starting off, it defines the level boundaries, and it decides where corridors can go. Corridors are basically drawn on the grid. It's a size of 2 by 1. This means that in a roll tournament, the slopes are actually, you cannot traverse a slope that's steeper than a 2 by 1 slope. So, but you can change that if you want. It's not limited to that. Same for the grid size. But by default, for a roll tournament, I would use those grid sizes. Now, this is how I built the grid. The grid is basically constructed from a set of components, and they're all put next to one another and above one another to create a larger grid. I started off with a cubic grid, basically only vertical and horizontal lines. But there was still a problem. You didn't actually have any places for ramps. So then I tried a cross grid, where I removed the vertical component and I changed it for a diagonal component. But again, I didn't actually have enough space to place the ramps because, as you can see in the lower left image, it's actually too steep. So in order to fix that, I stretched out the grid, where the diagonal components cross two horizontal components. So you would actually get something like this, and what you get then is you have enough space for the ramps, but the system also detects, it places these components based on the curves that it generates from the grid. So if you have a very long diagonal line, it would actually create this kind of staggered, like seesaw or a saw pattern. And in order to fix that, I only placed ramps in the middle of a diagonal segment, but left the ends of a diagonal segment to place flat components. So you get this stepped staircase. Works rather well for example, spiral staircases where it's a landing at the corners. So once I have the grid, we want to build the paths, the corridors or the catwalks on them. To do this, we first need a profile curve for that catwalk or the corridor. So I used Dijkstra's algorithm to do this. Used to have a starting point, an end point, and it finds the shortest path along the grid. I had Leroy Sykes produce me a custom Dijkstra's algorithm that was very fast. It also had to deal with other elements that I used for the pickup distribution. And here you can see how it works. So it actually finds its way to the end. And there you go. So once we have the profile lines, we actually want to assign the modules to it that will eventually form our corridors and catwalks. To do this, I had each point on the line analyzed for how many connections does it have. So the ones that have more than two connections are actually cross points. That's where small roofs will go, and it will just ignore those because we'll try to place small roofs there later on anyway. But for the other points where there's one or two connection, it takes the inbound angle in both the pitch and the yaw. It takes the outbound angle relative to the inbound, and it takes the orientation to the world. It translates these to a set of values. Like in the bottom here, you have a set of values for the pitch, and these are for the yaw. And then it combines those in a couple of switches to give you the different components. And each component is basically a smart asset. It can be scaled in width, it can be scaled in height. So if you want tighter corridors, you can do that, and it will just create those little corner pieces. For the AI grid construction, as I said, I started off with the separate segments. So you have the ground connections, and we have those long jumps. But in order to make that work, I also had to create 3 different types of grids from those for different types of player movement. So we have the normal connections for players that only would like to walk, or rather the novice players. They don't really know how to jump around, they tend to stay on the ground. And they can only fall down cliffs. Next to that, we have the advanced connections. These deal with players that can actually jump. And then we have the expert connections, which deals with players that use jump boots or a rocket launcher to boost themselves up further. Once we have these grids, we can do a risk calculation. For the pickups, actually are more interesting if some of them, for example, can be placed in more risky locations, whereas others prefer more tactical locations, and it changes the way the players behave. So firstly, I needed to calculate different variables. I did this by calculating the exposure, for example, like how many locations can see me for each location in the level. So for example, the most exposed area in the grid is actually a value of 1, and the least exposed location is a value of 0. I also did this for the amount of space that the player could move. So the more restricted the player is in his movements, the more risky it is for him because he doesn't have many ways out and he's more predictable. If you also combine that with the distance to a wall, so if the player is close to a wall, it means he only has 180 degrees to move, or in a corner even less. And then there's the height advantage. If you combine those two, you can actually detect if a player has an advantage or a disadvantage based on his height. So if I'm standing on a wall, someone's standing below me, then if I take a step back, he can't shoot me anymore because I'm out of his sight. If he's standing further away from me, however, if he's standing like in the middle of a room, I have to take a lot more steps back in order to be safe from him. So my situation is less tactical and his is less risky. And finally, we have the reachability. Do I need to jump or use a skill jump to reach a particular location? Some pickups, or the basic pickups, can actually not be placed in locations that the player can not reach without using a skill jump. So, for example, those points on those pillars there, those are yellow. That means they're jump locations, so you can only reach those by jumping. And the red dot up there is actually a location that you need a special jump for. And there's also There's the pickup placement. So basically the pickup placement itself is based on those variables, the risk calculation, and then it's also based on the hotspots. So hotspots are actually areas where you as a designer want players to converge, where you want them to fight. So what you do is you place the highest value pickups in these areas because that's what players go for. There's a concentration of high value pickups, that's where they're going to fight, that's where they're going to stay a lot more often, so that's where your combat's going to go. The system can define these automatically based on the sizes of rooms, but you can also place them yourselves around the level, and it moves along the grid in logical fashion, such as it won't go up hills that the player cannot traverse, for example. As I said, it's also based on the pickup value, so different pickups have different values, and it's based on the risk map. So say I have a rocket launcher, and the rocket launcher is placed in a hotspot, because that's where it goes, and it wants to find a risky location. So it will actually seek out the most risky location that it can find inside that hotspot, inside its possible area where it can be placed. But it will try to avoid locations that, for example, are not reachable. For example, if the rocket launcher is a default pickup, so it won't go on a location that's hard to reach for the player, so it will generally be at the bottom there, but not on those pillars. And finally, we have the area type. So some pickups prefer to be placed in rooms, some pickups will prefer to be placed in corridors, or others just don't care. And then there's also, for example, the center of a room or the sides of a room. We have ramps, can they be placed on ramps or not, objects, etc. And finally, it's controlled by two systems. There's the pickup placement rules themselves, so each pickup has its own definable placement rules. You can overwrite the defaults for the default pickups that you can find in the UDK, for example, or you can create your own custom pickups. And there is the archetype rules. So in what order are they placed? What archetype does a pickup belong to? And that's basically it. So if you have any questions, I think we still have some time. Ask away.
So in which thing does the tool run? 3ds Max, Maya, or any 3D program?
It's a tool that's made in Houdini. It's a procedural software package. It's also used for visual effects in the movie industry, and now more often in also the game industry for geometry generation and such.
You used a heat map, but how exactly did you use it?
I looked at how do the players behave in the levels, such as, for example, if there's a large concentration of kills somewhere, then why is that there? For example, there's one point in this heat map that I could show. Look in the bottom corner over there. There's a large heat spot there. That's actually because there's a couple of health pickups on that location that has, for example, a couple of boxes are on health. A couple of health pickups are located on a stack of boxes. The only way for the player to reach that is by either jumping or climbing those boxes. If a player is low on health, especially a novice player, it might take him a while to climb on those. If then an expert player comes past, he will shoot them and he gets a free kill. So that's why that area is actually more red than the others in this level, because we had a mix between expert and novice players.
Is that mostly because of health pickups or also just the normal weapon pickups?
It could be any pickup, but in this case, I think it's because players were low on health. They were looking for health pickups, because you can't pick them up if you have sufficient health. And then some other player came by and killed them. And I used that basically. I also detected how the players move throughout the level. I had another type of heat map that detected that by placing arrows in the level for the average direction that the player took. And that's basically answer to your question, I hope.
So you took that into account with the risk in notes, the algorithms?
In part, yeah, for the pickup distribution, how does the pickups, how are they placed throughout the level, where are they placed, and how do players respond to pickups? So that's how I assign their values to them.
Okay.
How did you clean up your volume voxel to have to be eventually changed to the the nice the grids? Because what you can see is you have like soft corners.
Oh, you mean the decorating objects? The
Yes.
decoration.
How did you clean that up?
Okay. So as you can see here, here's the high resolution grid. It's based on high resolution mesh, I should say. And I took that and segmented it. I originally tried to use boxes or blocks to just cut out pieces of the geometry, but that didn't quite work. So I chose to go with a lot of points, just a massive amount of points in a grid, and each point corresponds to one of those blocks, one of those segments. I did that for each of the directions for the walls. So this wall, for example, here on that side, it would have had a series of points in that order, and then it would assign a value based from that point. So it would actually find for each polygon in this shape, it would find the closest point and then give it that number. So in the end, I just had a lot of separate segments that basically you can see here in some way, and it would turn it into that. I also made the walls flat, so I actually flattened them based on their normal. So eventually, I only had flat segments to deal with.
Right. Okay. That's okay.
And then I took the bounding blocks of those objects and assigned them a mesh, scaled them a bit where needed, and assigned them to the different areas of the level.
Okay.
So with the initial design of the actual level, when you're choosing those sort of generative parameters to begin with that you can tweak, how did you decide what parameters there should actually be? Because I guess there's lots of things you could choose to sort of how it designs these initial sections, but I guess not all of them are useful, so was it just trial and error whilst finding the good ones? Or?
If I understand correctly, you're asking about how did I choose how and what order to construct the level? Or you mean
well, so at the beginning when it's deciding you've got the section, so you'll have a room here connected by corridor to another room.
Okay.
And obviously those rooms aren't just square rooms, there's other parts to them. How did you decide sort of what shapes they should be or what should affect the shape they should be?
You can change the amount of levels, for example, for the landmark rooms. You can change their shape, how complex they are, so from how many components they're constructed. And then you can also, for example, change the height levels of each height level. So, I mean, the height of each height level, I should say. So eventually you get a shape that you can use. You can also provide your own shape if you want. There's some limitations because it's based on the grid right now. But you can provide, for example, your own level shape from Maya, import that, and it will translate that to a room, for example. As for the entire construction of the system, I basically took a look at how does a level designer construct a level like these. I took a look at how would you approach it from a professional gaming standpoint. So I actually tried to find the best approach to just defining a level. How would I construct a level as a designer? So how would this procedural system go? Right? How would I progress through the system in order to produce a level that feels natural to me as a level designer?
Are you ever going to step away from the grid-based system?
I've actually been looking at that. I started off with the grid-based system because it's a prototype. For the first 10 weeks, I didn't actually know it was going to succeed in creating a playable level, let alone a traversable level. But in this case, of course, I didn't manage to do that around the 10-week mark, but I probably wouldn't have been able to do it if I would have just gone for a 360-degree environment where I would have had to deal with a lot more different angles and such. But I have been looking at that. I have been looking at how can I make these corridor segments 360 degrees, a bit more organic, for example. And I think if you use a more high-density grid and you use a spline curve that just based on points, then it can create more organic shapes for the corridors, for example. But I have to look more further into that. This is really a process of discovering while you're building it most often. Any more questions?
Will you use for each different states, from breaking single rooms to corridors with different nodes?
For the first segment, for the level shape, basically, as you can see here, different areas. Yeah, I did try to start off with different digital assets, as I call it. However, for the last stages, like the object placement, that's its own separate node, and then for the entire pickup placement, because those grids and the pickups themselves are related to one another, that's also one separate node.
Yeah. So multiple nodes to create this.
Well, for the entire level geometry generation, yes, I have separate nodes, but I combine those in a master node. So you can just place that down. You don't have to reconstruct the entire network. That's it's all ready.
Do you have any idea if you could implement some form of analytics on what you generated and what the most likely movement paths were going to be, and also with multiple players in the same level. So not just generating the most likely paths, but also generating the most likely paths correlating to someone else's position if the player knows that he's there.
Well, right now I can, for example, detect the fastest path throughout the grid, throughout the level, by basing it on the grid and different types of player movement. But that's not exactly your question.
No, for example, placing a player on a certain location and then calculating based on how big the threat of that player is, how the movement path would change on your grid.
It's not included in the generator right now.
Obviously not, but do you have plans for that? Because I think from a design perspective that is very interesting to know before you actually start building a level.
I haven't actually thought about it so far, but I could take a look at it as well. So, I think we're out of time.
Yeah.
And I thank you for coming to this presentation. I hope that you found it informative and have fun with the other presentations.